page 9 in your notes. You should be on page 9 in your notes. We talked about this already today. To find the slope, you can draw a slope triangle and you look for the change in y, delta y over delta x. Delta y just means you subtract them. When you see this like written like this, you guys, y little 2, y little 1, that just means we were given 2 points. And the first point had x1 and y1, and the second point we call x2, y2. We're just given 2 points, and one of the points we call the first, one of the points we call the second. That's all those little numbers mean. It's not like you're squaring anything. They don't mean anything fancy. It just means I take that y from the second point and subtract the y from the first point, and then put it over the x from the second point minus the x from the first point. Guys, I'm talking. You guys should be joining me in the notes. So those are our 2 formulas, delta y over delta x, or you can, like if you draw your slope triangle, or you can do the subtraction. Then we also write an equation here. Remember, m is the change. M is the delta y over the delta x. M is the slope. That's what we think of when we talk about m. B is the initial value. B is the start. B is really the y-intercept, where it crosses the y-axis. So when you think of M, you think of slope. When you think of B, you think of the intercept. So when I am looking at this particular graph, it crosses at 2. That's why they have a 2 at the end. And then my slope triangle is change in y, 1, change in x, 3. That's why they have 1 over 3 here. Okay, we're going to be doing a lot of that when we work today. All right, we're going to apply slope, but now we're going to apply slope to a certain situation. I'm sorry that these are not super clear, but I'm going to put my first point at the corner here, and I'm going to put my second point above 4. Because that's where it looks like it crosses nicely. It's sort of hard to see, but if you look really closely, you can kind of see it. So when I do my delta y over delta x, I'll do that line up and over. What is delta y? I went up to 5. Yep. And then what is delta x? 4. So what is my slope? 5 over 4. And I'm going to put it to some meaning to it. It's 5 feet for 4 years. When I need to describe what's happening, I would say this thing grows. There's a growth of 5 feet in 4 years. That would be my description. When I look at B, I want to do the same thing, except for in B, I have a little bit of a problem. What's delta y? 0. So I'm going to put a point here, and I'll put a point over here, and count my change here. All I have is a delta x. Delta x is 1, 2, 3, 4, 5, so that's 5. Delta y equals 0 because it doesn't rise. So this is 0 feet. Is it 6? 1, 2, 3, 4, no, 5. Just remember to count the spaces in between. 0 feet in 5 years. How would you describe this one? What's the growth like?
0.
No growth at all.
No height over.
No growth. Let's do my next one. I'll start here, go up to here. What's delta y?
Is it 2?
Delta y is 10. What's delta x?
2?
Does it move over at all? No. 0. So we say 10 feet in 0 years. 10 feet in 0 years. I heard somebody say that that is undefined, and I agree. That's an undefined slope because you can't divide something by 0. So my slope is undefined. How do I describe this? How would you describe this thing? How is it growing? It's a straight line up, but if I had to describe it in terms of growth, what would you think you'd say here? It's growing constantly and quickly in no time. So it just is growing and growing and growing and growing and growing and growing, and it doesn't stop in no years. It's just endlessly growing if we could freeze time. Going back to B, what would I call the slope for B? Is that undefined? No. What's 0 divided by anything? 0. So that would be a slope of 0. If I could go back to A, what's the slope? 5 over 4. Okay, now, A was rising, B is flat, C is undefined. What about D? I'm going to find points, try and find points that intersect a spot, it looks like here. What's delta Y?
Wouldn't it be
I heard 5, but it's dropping 5, so negative, yep. And then what's delta X? 4.
8?
So what's my description? This is
Negative 5
it
over 4.
drops 5 feet in 4 years. It is negative 5 over 4. How would you describe that? It's shrinking. It shrinks 5 feet every 4 years. Okay? So let's put that into action into what we call a race. Okay? So there's a lot to think about, and you guys, you're going to be on your own on a very similar problem tomorrow, or not tomorrow, Monday for virtual. So I want to think about what we're doing. We have to read this whole thing. Before a big race, participants often compete in heats, which are preliminary races. If any of you have done like track or any, even like go-kart racing or BMX racing, things like that, it's the same thing. You usually participate in a preliminary race to determine who gets to compete in the final race. And so we're going to do the heats, we're going to do the preliminary races, and you're going to be in charge of doing the big race, the final race for your homework on virtual on Monday, okay? So in the first heat, we have Leslie, Kristen, and Evie. And they're riding tricycles. This is a tricycle race.
Evie or Evie?
Evie. It says it right in front of you.
Oh, it's got-
Yep, Evie. And so Leslie began at the starting line, and she rode at a constant rate of 2 meters every 1 second. So Leslie starts at the starting line. So I'm going to graph that. She starts at the starting line. Starting line is right here at 0, 0. And it says that she rode 2 meters every second. So I'm going to do her in this blue color. 2 meters every second. Starting line, rode 2 meters every second. So here we go. That means up 2 over 1. Up 2 over 1. I'm going to continue this.
You do that the whole way?
Yep. Fill in your whole graph.
I bet I can go faster than you.
Oh, race is on.
Finished. All done. Nick wasn't part of the race.
We had our own big race here. Okay. So this one's Evie. I did. Oops, sorry. This one's Leslie. Okay. Now I want to do the same thing, but now I'm going to do Kristen's information. Okay. So let's do this one. It says Kristen got an 8-meter head start, and then she rode 2 meters every 5 seconds. So what do you suppose that means if she got an 8-meter head start? So right here, I'm reading, Kristen got an 8-meter head start and rode 2 meters every 5 seconds. What is it? Yep. So Kristen starts at 8 meters. 1, 2, 3, 4, 5, 6, 7, 8. There's Kristen. I'm doing Kristen. Kristen's going in purple on my page. If you have different colors, you can use them. If not, it doesn't really matter. But we'll have to label the lines when we're done. Okay? So here's Kristen. Kristen rides 2 meters every 5 seconds. So that means up to over 5. 1, 2, 3, 4, 5. Up to over 5. Up to over 5. 1, 2, 3, 4, 5. Up to over 5. Up to over 5. Okay.
How come we got different answers?
I don't know.
I was one off.
Okay. They're sort of small. You have to be a little careful. Okay? So that was Kristen. I did Kristen's in purple. I'm going to do Evie's in green. That's how I'm going to do mine on mine so it stands out. And it tells me that Evie rode 5 meters every 4 seconds, but she got a 6-meter head start. So 6-meter head start means she starts at 1, 2, 3, 4, 5, 6. So I'm going to start Evie right there. Now I have to translate her. It's 5 meters in 4 seconds.
So we go up 5
So
over 4.
up 5 over 4. Very good. 1, 2, 3, 4, 5 over 1, 2, 3, 4. And now we have to finish counting from there. 1, 2, 3, 4, 5 over 1, 2, 3, 4.
I never seen Kristen this much. So it's one of the others.
Uh-oh, I'm off the chart now, so I can't go any more than that. Oops. It would be off. Okay. I'm going to sort of connect these points so I have kind of a line. I'm going to do the same with the other guys. Purple. And the first one that I did actually was the blue, and my blue ran out. Okay, I'm going to label these lines. The blue one was Leslie. Leslie. Okay? So I'm just doing a little arrow. The green one was Evie. Okay? The purple one is Kristen. Okay? So there I go. I labeled mine. Up next, they want us to write an equation for each of them. So I'll start with Leslie. Where did she start? 0. How did she change? Up 2 over 1. So Leslie is, remember it's change is 2 over 1. Start was 0. So Leslie's equation is y equals 2x plus 0. Why didn't I put 2 over 1? I don't really need to. Yeah. Do I really even need the 0 at the end? No. Okay. Now I want to do Kristen's. Kristen's change and start are what I need. Where did Kristen start? 8. And how did she change? Up 2, oh, beautiful, up 2 over 5. Perfect. So y equals 2 over 5x plus 8. Up next, Evie. I need Evie's change and Evie's start. I heard Evie start at 6. Her change is what?
5 over 4.
5 over 4. So y equals 5 over 4x plus 6. Now let's answer some questions.
I think I understand now.
Okay? So I have all my lines labeled, and the question first asks, in how many seconds did Leslie catch up to Evie? How'd you get that? You counted where they crossed, right? Very good. And that happened in 1, 2, 3, 4, 5, 6, 8 seconds. Yeah, if you're off on your graph. So, and I'm doing Leslie and Evie. So it took Leslie 8 seconds to catch up with Evie. 8 seconds. Okay? And then it says, how far were they from the starting line? How many meters? How many meters? 16? Okay. I got 17, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Oh, 16. Okay. 16 meters. Great. Okay, we've got another question. The winner of this heat will go to the big final race. If the race is 20 meters long, who won? So the winner of this race, or the winner of this heat, will race in the big final race. If the race is 20 meters long, who won this second? Or who won this race? So this was 16, right? 17, 18, 19, 20. I'm going to just draw a line here. Who got to 20 first?
I did.
Leslie. Now it asks us how we could find this out algebraically. And we could do that by setting the equations equal to 20. That's how I can do it algebraically. I'm not going to do it because I have the graph in front of me. And I see that Leslie got to 20 first. And so we don't need to do that. But if I needed to, if I didn't have the graph in front of me, I could set each of my equations equal to 20 and figure out how long it takes them to get there, okay? So up next is, how long did it take each participant to finish the race? So let's take a look here. I'm going to have to do some counting again. I'm going to try and eyeball this. So I just sort of put them in about where it looked like they crossed the line. And the only one that was a little off right here was the one I did in green, that was Evie. But we can approximate it still. So what would you say Leslie is? How long did it take her?
Leslie, how long did it take?
10 seconds.
I lost about 5.
Okay? And then Kristen. Kristen was way over here. Yeah. Kristen is, if that was 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28, 29. Did anybody else get 30?
30.
30, yeah. For Kristen, I got 30 seconds. And then what about Evie? Yeah, it looks to me like 11 and a half. So I just counted. Again, I'm matching. We put in the 20 finish line, and then I eyeballed where they crossed. And then I had to do a little counting on here. That's pretty close together, but they ask us one more question. It says, the school newspaper wants to report Kristen's speed. How fast was Kristen riding? Kristen, here we go. How do I translate that? It's 2
meters
per,
5 seconds.
beautiful, 2 meters in 5 seconds. If I had to write that as a unit rate, that means make the bottom 5. So it would be, or make the bottom 1, it would be 0.4 meters per 1 second. How did I do that? I did 2 divided by 5. 2 divided by 5 gave me 0.4. All right? We've got another heat to do before we're done. Yep, one more race. Oh,
That was the hardest note to play.
was it? Okay. What's that? Okay. All right. But did you notice how it was a little bit difficult to work on that graph? Especially it was tiny and we were trying to count and things were a little, so we're going to work through a little bit differently. In the second heat, we have Elizabeth, Kay, and Hannah. And we're going to just kind of answer the questions with the equations that we have. Okay, so when the line representing Kay's race is graphed, this is the equation. Tell me what this means. What does this 1 mean? That means she got a, what kind of head start?
1 meter head start.
1 meter head start, yep. 1 meter head start. How do I interpret the 2 over 3? What's that?
You got 2 meters every 3 seconds.
It's 2 meters every 3 seconds. Excellent. So let's do the next person. Elizabeth. What does this 4 mean? This is a 4 meter head start, yep. What does this 12/16 mean? Okay, it asks me, who is riding faster, Elizabeth or Kay? How can you tell? Yep, so I have to compare 2 over 3. I have to compare it to 12 over 16. 2 over 3 compared to 12 over 16. Well, I can reduce 12 over 16, right? Divide by 4, that's 3/4. I still need to figure out which one's bigger. So what I usually do is I'll just take my calculator and I can divide it. So I do 2 divided by 3, get that answer. That's 0.6 repeating. So this one is 0.6 repeating. Then I do 3 divided by 4. That's 3 divided by 4. That gives me 0.75. Which is faster, 0.66 or 0.75? 0.75. So who's faster? Elizabeth. Faster is Elizabeth. Okay. Just as she started pedaling, Hannah's shoelace came untied. Be careful not to get her shoelace tangled, or being careful not to get her shoelace tangled. In the pedals, she rode slowly. Hannah's race is represented over here. We need to find the rate at which she was riding. So our time is our delta x. What's the change here? $14. Yep. 14 to get to 28 is 14. And this is my delta y. What's the change on the other side? 4. So what is my delta y over delta x? 4 over 14. Okay? And if I want to write this as a unit rate, I'm going to take and divide 4 by 14. So this is where our calculator comes into play. And I got about 0.286-ish. And this would be meters per second. That would be my unit rate. So I figured out my change in y, my change in x, put it in this form, and then I divided them to find my unit rate. Okay. To entertain the crowd, a clown rode a tricycle in the race described by this equation. Without graphing, let's make it, or making a table. What happened to the clown? He started where?
20.
And then what did he do? He went backwards. He rode backwards 1 meter per second. Do you guys see this line that I put here, this slash? Yeah, that means per. And when we talk about slope, that's kind of what we're talking about here. Okay, so let's do a quick explanation of these things. Can you guys describe what's going on here?
It's going up 5 meters every 14 seconds.
No, really?
Sure. Oh, 5 feet every 14 years.
It's growing 14 feet every 5 years. Growing.
What about the 0.42?
14 feet every 5 years. Okay? So, what about what?
The point 14, what do we do with that?
The point 14?
After the 5.
Oh, that's 5 comma 14.
Oh,
And that just tells me how far we moved. Okay, so now, is it 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't think it's 14. What's this guy here? That's 4. So really, how much did it grow? 10. This should be 10 feet every 5 years. Okay, now, how tall is it when they planted it? Great. Yep. Okay. Let's interpret what's going on here.
they're going up $150 every 2 months. I think.
It looks like they're going down,
Yeah.
down 20 every how many months?
2.
Every 2 months. 150 to 130. Down 20 every 2 months. So what is this? The balance is dropping $20 every 2 months. Okay, tell me, how much did they start with in the bank? How are we counting?
Oh, they started with 170.
Yeah. Okay. How about this next one? Last one, kind of the same thing. We're going to go through that. What's the scenario? Let's do our slope triangle to help us out here. How does the y change?
Goes down,
From 44 to 88, it goes up 44. And then from 2 to 4, right 2. So this is, how do I interpret this? We go how many miles? 44 miles for 2 gallons. So drive or ride or whatever, 44 miles on 2 gallons. Where did they start?
they started off at 2.
Way down here.
All the way in the bottom?
Yep. Yep. Well, it depends. So, like, this one started where it hits the axis. So this one started at 170.
Whichever was the line starts.
Yep. So this one started at 4. All right. So, no homework tonight. We worked a lot in class. But your big race is your homework for Monday, and I'm going to hand you